Hey everybody, this is Mr. Benson. I'm going to show you how to solve some of these problems on this practice test you just took. We start by zooming in a little bit, just a little bit. Yeah, there we go. That's maybe too much. There we go. Okay, so first problem asks us to find the domain of each radical function, given right here, and it gives us a way to answer it, something like that. The key thing algebraically to solve this type of problem, what you want to do is you want to take this radicand, this thing I'm circling in red, you want to take that 12x plus 24, and you want to set that greater than or equal to 0. That's step one, is setting that greater than or equal to 0 in this situation. Now when we look at this whole thing, we'll notice that there's no x squared there, so our goal is just to get this x by itself, and once we do that, we'll have our answer. I'm going to start by subtracting 24 from both sides. So I have 12x is greater than or equal to negative 24. I don't know why I put that one there. And then I'm going to divide by 12. Divide by 12, and I have x is greater than or equal to negative 2. And so my solution should be x is greater than or equal to negative 2. I'll start by putting that x is greater than or equal to negative 2. Check that out. See, there we go. We're all good to go on that one. You can also do this problem by graphing it. I'll show you how to do that. So you go y, start by putting in the function equals square root of 12x, was it plus 24 or minus 24? Plus 24. Plus 24. And if you look at this graph right here, we notice that we're just trying to find the domain, right? Where all the x values are. And the domain seems like it's to the right of negative 2. And so notice how we start at negative 2, and the x values are, see this x value is greater than negative 2, and this one also, this one, all these values right here, all these green dots, they're all greater than negative 2, so x is greater than or equal to negative 2. And that's how you can kind of read these graphs to answer problems just like that. Okay, let's move on to the next one down here. Oh, I was hoping it would scroll with it. I guess not. Clear the ink. Number 2 says to rationalize the denominator in simplified form. So the key thing to do is multiply, I'm blanking on the word, by the complex conjugate, or maybe it's just a conjugate. Multiply by the conjugate. So to determine what the conjugate of the denominator is, we need to find the radical part of it. This is the radical part of it. And because the sign of the radical part of it is positive, we are going to multiply by 4, now minus the square root of 2. Okay? And you got to do that on top and bottom. 4 minus square root of 2. Okay? So, now that we have that, we got to figure out what this top is. Let's start with our top. Our top is multiplying the 2 times 4. Well, that's just 8. And then the 2 times the negative square root of 2. Well, that is minus 2 square root of 2. We're not taking 2 times 2 and we get the square root of 4. It's 2 times the square root of 2. So that's what our top is. Okay? Now let's figure out what our bottom is. We're going to do this one in green, and we're going to make a little box right here to do it. And I'm going to take this part right here, 4 square root of 2. I'm going to take this part right here and put it on the side, 4 negative square root of 2. And you're going to see what's going to happen, because remember, our goal is to get rid of this radical on the bottom. That's our goal. So hopefully, when we do this, there will be no radicals in the end. Well, 4 times 4 is 16. We know that. And 4 times negative square root of 2 is negative 4 square root of 2. And then 4 times square root of 2 is 4 square root of 2. And square root of 2 times negative square root of 2 is negative square root of 4. Now, what is the square root of 4? Well, it's 2. So this is really equal to negative 2. Okay, now with this in mind, let's see if anything cancels. Well, check out these square roots of 2 that we have here. That and that cancel off. So those are gone. And so really what we have is we have this 16 and this negative 2. Well, 16 plus negative 2 is equal to 14. 16 plus negative 2 is 14, and that is going to be our denominator. We're going to put that right here. Okay. Now, I would love to say we were done at this point, but we're not. If you look at each of these terms, this term, that term, and that term, they're all even. And if they're even, that means we could pull out a 2 of each of those terms. Let's do that. If we pull out a 2 on the top, we're left with a 4 here with the 8, and we're left with the minus square root of 2 here with the 2 square root of 2. Okay? And if you pull a 2 out of the bottom, we're left with 2 times, what's left out of 14? Well, 14 divided by 2 is 7. What you can do is cancel that 2 with that 2, and what you're left with is 4 minus square root of 2 all over 7. And that's what we got to put into Moodle. Right there. 4 minus square root of 2 all over 7. So, we'll put it in like this. 4 minus, and you can do it 2 ways, because square root of 2, you can just go right to the bracket. But let's say it was square root of 3. We would use parentheses, but it's not. It's square root of 2. So, no, I mean the third root. Sorry, I said that wrong. Okay, so 4 minus 2 bracket, what was in parentheses? 2. Okay, and then we are going to divide this whole thing by our bottom, which was 7. Okay, and so notice this, what I got here. So I have my 4 right here, that's from this. I'm subtracting, that's from that. This 2 right here is my index that was given right there. This 2 is what's under the square root right there. And then I'm dividing by 7 right there. Okay, so that's how I get that problem. And let's check it, see how that one goes. Check it. Oh, too much stuff in front of it. It's clear ink. Check it. And there we go. There's your final solution to that one. Now you could also put parentheses on top too. Let's see if that does it. I have this in many ways, and I'm going to be looking for this when you're taking the test to make sure you have it right. Okay. Ooh, for this one we want to find the domain of this. Let's just do this one the easy way by graphing it. Okay. So we're going to put this into our graphing calculator. Let's find that graphing calculator. We got the square root of x squared minus 2x minus 3. Square root of x squared minus 2x minus 3. Okay, so we have that in there. And now we need to find the domain of this, knowing that. Okay, so first let's look at this part of the function right here. Looking at this part of the function, so we have this. Remember, our starting point is -1. Okay, so we want to figure out what x values are these. Are these x values greater than -1 or less than -1? Well, they're less than -1, so we have x is less than or equal to -1. And then let's look at this one. That's one of our inequalities, or. And then I have these x values right here, starting at 3. So I also have x. Look at all these values on this part of the function. These are all greater than 3. Okay, because they're all greater than 3, we're going to have x is greater than or equal to 3. And so that's what we have to put in our function. X is less than or equal to -1 or greater than or equal to 3. So I'll show you how to plug that in there. If x is less than or equal to -1 or x is greater than or equal to 3. And then we check that out. See what we get. There we go. That's question 3 done. Moving on to question number 4. Okay. Question number 4, we need to actually simplify this and think PEMDAS. PEMDAS when we're simplifying this. Parentheses, exponents, multiplication, division, addition, subtraction. Okay? So what we want to do is try to work our way from the inside out. And the most inner part of this is this -8 to the third. So we're going to try to figure out what -8 to the third is. We'll put that in our graphing calculator. So we got -8 to the third. And that's -512. Okay? So let's just rewrite this whole thing as 1/8 times the third root of -512 squared. Okay, so now we got to figure out what this third root of 512 is. Remember, the third root of -512 is equal to -512 to the 1/3 power. That's how you could put it in your calculator. So let's do that. -512. Oh, make sure you put that in parentheses. Don't make the mistake I just did. 512 to the 1/3 power. Let's see what that is. Oh, we're back down to -8. Okay, so we just didn't do anything there, looks like. So now we're at 1/8 times -8 squared. Okay, now we're in a range where we can just do this in our head. What's -8 squared? Well, -8 squared is 64, so we have 1/8 times 64. Well, this is the same thing as 64 divided by 8. And what's 64 divided by 8? That's just 8. So our final solution to this thing is 8. You can check that off. Perfect. Okay, let's move on to number 5. Okay, now number 5 is from 8.6. And really what you got to look for is 3 parts. There's one general form of the equation for doing a problem like this. First, we got y equals a times the absolute value of b x minus k plus h. Okay, each of these things, the a, the b, the k, and the h, do different things. Now the a is the vertical stretch. It also might flip it over the x-axis, okay? The B is the horizontal stretch. It also might flip it over the y-axis, okay, if it's a negative. The K is the horizontal translation. Really the horizontal movement translation, and that's the same thing. So it's going to move it right if you look at it and it is a negative, okay? It's going to make it move left if you look at it and it's a positive. And lastly, we got the H. The H is the vertical translation. That makes it go up if you look at this H right here and it's positive. It makes it go down if you look right here and it's a negative, okay? So now with that in mind, let's take a look at this function. We have this 4 right here. The 4 is, which part of this? This is the A. 4 goes along with the A, so that is your vertical stretch or translation. So right here for this part, we'll put a 4 right there. Your horizontal stretch, we look at this, there's nothing really in front there. There's no B there. So some people think, oh, let's put a 0 for that. But if you put a 0 in front of the X, that zeroes that out. So really it's a 1. That's what you want to put in. That's your horizontal stretch. It's a factor of 1. Really doesn't stretch it at all. It's just a factor of 1. Then we got the horizontal translation. That's this one. This is going to tell if it moves right or left. Because it's negative, it's going to move it to the right, which means that's really a positive 2. You want to put a positive 2, the opposite of what is actually there for the horizontal translation. And for the vertical translation, that's this -1 right here. That's your vertical translation. So that one's exactly how you would expect it to be. It's going to move it down 1, so you put a -1 there. Check that, make sure I got those right. There we go. Okay, let's get started on the next 5 problems right here. So here we got, oh, what's going on here? Here we're just trying to combine, or we're trying to add radical expressions right here. When you're doing a problem like this, what you want to do is like combine like terms. That's the goal right here. So like terms in this situation is kind of weird because there's no x's and y's, but there are square roots, and you want to treat those like they're x's and y's. So if you had something like the square root of 2, treat that as like an x. If you had something like the square root of 3, you treat that like it's a y. And if you had x plus y, could you bring them together to make it 2xy? No, you couldn't do that. So if you have the square root of 2 plus the square root of 3, you can't bring those together either. Just like that, okay? So what we're going to do is we're going to try to combine like terms right here. I'm noticing this 3 and this 1 add together really nicely. 3 plus -1 is just 2. So those are combined. Well, now I want to take this square root of 18 and add it to -4 square root of 2. Here's the issue, though. Square root of 18 is not the same as square root of 2. We need to make them the same, and if we can't make them the same, if we can't, then we can't combine them together. So what we want to do is, I know square root of 2, that's as good as it gets. You can't really simplify that one down. But the square root of 18, I think you can simplify this down. Because I know that 18 really breaks down into 9 times 2. And so we really have the square root of 9 times 2. And that is actually equal to the square root of 9 times the square root of 2. Okay? And we know that the square root of 9 is 3. So we really have 3 square root of 2. So this square root of 18 right here is really 3 square root of 2. But we're adding this -4 square root of 2. So plus -4 square root of 2. So imagine this. We have 3 square roots of 2, and we're adding -4 square roots of 2. In other words, we're just subtracting. We're subtracting right here because so what's 3? Ask yourself, what's 3 minus 4? Well, 3 minus 4 we know is -1. So what we have is -1 square root of 2. But there's no need for that -1. You could just say we have a negative square root of 2. Okay? So let's not forget about our red 2 up here. We had this 2 when we combine these together. So we have 2 minus square root of 2. And that is your final solution to this one. We just got to get into Moodle. We got 2 minus, there's 2 ways to put this in. You could go parenthesis 2, bracket 2. Or you could do, because it's square root of 2, the square root means you really don't need this. Or take either way. Check that. There we go. Okay. Moving on to number 7. That was 6. Let's clear the ink here. Okay. Now, we need to simplify this as much as possible. One thing I know, because Mr. Benson told me, and I'm Mr. Benson, is that this square root and this 1/2, they're the same thing. So really what we have is the square root of 64x to the 7th all over the square root of 4x squared. And when I'm taking two square roots and I'm dividing them, I can just say that I can have one big square root of 64x to the 7th all over 4x squared. Okay? And now, at this point, what I'm going to try to do is I'm going to try to take what's on the inside here and simplify it down as much as possible before I take the square root of it. Well, I know that 64 divided by 4 is 16. Right there. That's 16. And I know that x to the 7th is divided by x squared is x to the 5th on top, because you have 7 x's on top and 2 on the bottom. So if you cancel the 2 on the bottom with 2 on top, you're left with just 5 x's. So we're trying to find the square root of 16x to the 5th. Well, I know that the square root of 16 is 4. So I got 4 square root of x to the 5th. Now I got to start taking out groups of 2 x at a time, because this is an index of 2. So let's bring this out. I got 4. I'm going to break this up. 4 square root of x squared, because I'm breaking up into groups of 2, x squared and x. Notice the x squared and this x squared and that 1 that's right there. I just don't write it. That gives you 5 when you add them all together. Now, I can take each of these x squareds out. But when I take that x squared out, it becomes a 1x. And when I take this x squared out, it becomes a 1x. And sadly, this x I can't take out because there's only one of them. I need 2 in this situation. So my final solution would be 4 from this 4, x squared from these two x squareds, times the square root of x. That's your final solution to this problem right here. Okay, let's just plug that sucker in and move on. We have 4x squared bracket, because it's a square root, we don't need that index thing, x. 4x squared x. There we go. Moving on to question number 8. Okay, for question number 8, very similar scenario. Now instead of division, we're multiplying. So what I'm going to do is, because I got 2 square roots right here, they're the same thing, I can put this all under one radical. So I can say this is 2y to the 3rd times 8y to the 6th. Now I can multiply these two. So I got the square root of 16y to the 9th. Okay, we already figured out what the square root of 16 was in the last problem. So I know this is 4 square roots of y to the 9th. Now how many groups of y can I take out of there? Well, let's do that. I got 4 y squared, that's 2, y squared, that's 4, y squared, that's 6, y squared, that's 8, and we have one more y, that's y to the 9th. Now remember, each of these groups of 2 y's I can take out of here and make 1. Okay? Because really what I'm doing is I'm taking the square root of x squared, and that's just 1x. The square root of this x squared is just 1x. The square root of this x squared is just 1x. And the square root of this x squared is just 1x. Sadly, this last x does not, you can't take the square root of that at the end and simplify that. So my final solution, if I rewrite this whole thing, I'm going to do that right here. I have 4 from this 4. How many x's did I have? I had 4 of them, so that is x to the 4th power times the square root, and what was left over underneath? Just an x. Okay, now I need to put that in Moodle, and I'm done with that problem right there. Let's see, can I see it? Yeah. 4x to the 4th bracket x. I think I put that in right. Yeah. Okay, check that out. What? Oh. Where did Benson go off on this one? What did I do wrong? 4 bracket. Did I not put the 2 in? Do I need that 2 in there in this one? Checking that one. Oh, I see what I did wrong. Look at, they're y's. They're y's in the problem. So make sure you put y's, because they started with y's, so you should put y's, not x's like I did. Don't make this the same mistake I did. Okay. That's better. Okay. Now clear the ink. We're moving on to number 9. Okay, now we're multiplying 2 binomials that have radicals in it. To do that, you've already done a problem kind of like this, actually a little bit harder. We're just going to make our box. So we got 7 negative 2 square root of 6. I got 7 2 square root of 6. Okay, so 7 times 7, we're going to multiply in here. We got 49. 7 times 2 square root of 6 is 14 square root of 6. 7 times negative 2 square root of 6 is negative 14 square root of 6.
Here's the biggest mistake that students make. We got 2 square root of 6 times negative 2 square root of 6. That's negative 4 square root of 36, not 6, okay? Now, what is this equal to? What's the square root 4 times square root of 36 equal to? Well, that's equal to negative 4 times 6. And negative 4 times 6 is really equal to negative 24. So this is really negative 24. Okay. Now let's combine like terms. We got this negative 14 square root of 6 and this positive 14 square root of 6. Those cancel off. Those are gone. And what we really have is 49 plus negative 24. Well, 49 plus negative 24 is 49 minus 24, and that's equal to 25. So our solution to this one is 25. 25. Check that. Nice. Okay, clearing the ink. Moving on. Okay, here we're going to also have to remember we got to rationalize the denominator. Mathematician one day said no square roots in the denominator, so we got to get rid of that. Okay. Well, let's I don't know. There's all these different ways you can go about doing this. Let's bring this into one radical, and so just say this is 3 over 27. Let's start with that. Well, I know 3 divided by 27. I can divide these both by 3. I can pull a 3 out, right? So I really have the square root of 1, because 3 divided by 3 is 1, and 27 divided by 3 is 9. So I got 1 over 9. Remember, you can only multiply and divide top and bottom. You can't add or subtract. Well, now that I have this, I could actually break it up again. Check this out. I could say this is square root of 1 over the square root of 9. And we all know that the square root of 1 is 1 times 1 is 1, so this is equal to 1. And what's the square root of 9? Well, that's just 3. So our final solution is just 1/3 on this one. So let's put that in there. 1 divided by 3. Check that. Okay, I'm going to take a break on this. Okay, let's start on question number 11. We want to simplify this radical expression right here. What we have is the square root of 98x to the 7th. Well, this one's tough to figure out because of this 98 here. What you want to do is you want to take that 98 and you want to break it up into its primes. So we know that 98, what is that? That's 2 times 40, 49. And that's prime. That 2 is prime. Oh, and 49 is 7 times 7. Oh, that went actually faster than I thought it would go. So when we write this, we can write this as the square root of 2 times 7 squared. Remember, we had 2 7s, so we can say 7 squared. And then the 2 came from this 2 right here, times x to the 7th. Now, because it's a square root, we're going to look for groups of 2. And for each group of 2, we can pull it out. So let's kind of rewrite this as this is square root of 2 times 7 squared times, and we're going to need as many groups of 2 of x that we can make. Well, this is 2, and this is 4, and this is 6, and now we only have 1 left to make that last one, because 2 plus 2 plus 2 plus 1 gives us that 7 right there. Okay, so we're going to pull out groups of 2. Each time we pull out a group of 2, there's only 1, because the square root of 7 squared, well, that's just 7. And the square root of x squared is just x. And again, the square root of x squared is another x. And the square root of another x squared is just another x, right? That's what happens is when we pull them out, they just become one of them. So let's rewrite what we have here. We have a 7 from here. How many x's do we have? We have 3 x's, so that's x to the 3rd times the square root. And what's left underneath? We have that 2 and that x right there. So this is a 2x. We don't need to do the 1 power. That's kind of a waste of time. So that's your final solution to this one. We have 7 x caret 3 bracket. Again, you could put it parenthesis 2 before that, and you put 2x right there, and then check that. There we go. Moving on, number 12. Number 12 is finding the difference for radical functions. Remember, we're going to combine like terms. This one's actually a little easier. Check it out. These are the same. The square roots are the same. So we're going to combine this 4 with that negative 3. So what is 4 minus negative 3? 4 minus negative 3 is equal to 4 plus 3, which is 7. So these two give you 7. Okay, I'll put that right down here. Now let's do this one. Think of this as a 1 square root of 7. So we have 1 square root of 7s minus 2 square root of 7s, right? 1 square root of 7s minus a positive, so 2 square root of 7s. Well, what's 1 minus 2? 1 minus 2 is negative 1, so really we have negative 1 square root of 7. But we don't need that negative 1 there, so we can just say it's 7 minus square root of 7. That's your solution to this. I know you might say, oh, can't we factor out 7 out of these? No, because this 7 is under the square root, so that one has to stay in there. So let's plug this in there. We have 7 minus factor or bracket 7. And there we go. Check that. Great. Okay. Moving on. I'll solve the following radical. Okay, so we got to solve this radical. Remember, when we solve things like this one right here, after solving it, you also need to check to make sure it's the right solution, unless you remember that trick. Remember, where the trick is, once you get this radical by itself, it's equal to a positive number, you know that's going to be a correct solution. Well, the first step is to isolate this square root by itself. And to do that, what we're going to need to do is we're going to need to divide both these sides by -4. -4, okay? So once I divide these sides by -4, what I get is I got 12 minus 3x is equal to -24 divided by -24 is 6, okay? Now at this point, what I need to do is I need to square both sides, okay? Because I want to get rid of this square root right here. That's my goal. And if you square it, you cancel it off. So what I get is 12 minus 3x is equal to 36. Now what my goal is now is to solve for this x here. So I'm going to actually, let's rewrite this up here a little bit. I'm going to rewrite this right here. I got 12 minus 3x is equal to 36. I'm going to subtract 12 from both sides, subtract 12. So I got -3x is equal to 24. And I'm going to divide both sides by -3. -3. Did I do that right? Yep. So I have x is equal to -8. Okay? So now, let's take this -8 and check it. Now I already know that it's going to check out because once I divided by the -4, notice how it was equal to a positive once I isolated this. But just in case you don't remember that, we're going to put this -8 in there and we're going to check it. We'll check this over here. So I got -4 square root of 12 minus 3 times -8 equals -24. Well, this is -4 equals times the square root of 12 minus 24. But it's positive 24 because we got the double negative right there. Equals -24. So we got -4 square root of 36 because 12 plus 24 is 36 equals -24. We know the square root of 36 is 6, so we got -4 times 6 equals -24. And this indeed does equal to -24 equals -24. So it does check off, and so our solution is -8. -8. There we go. Checking that. Perfect. Okay. Now we're going to solve this one. Actually, this one's kind of nice. Clear ink on this one. Notice that both these sides already are squared, right? Or a square root. And so our first step is to isolate them. Well, they are isolated, so we're going to square both sides. When we square both sides, we're just going to have what's left underneath. So in this situation, I have my p plus 3. I'll put that right here, p plus 3. And then here I got my 2p minus 1 equals 2p minus 1. So now it's all about solving for the p. Let's get the p's together on one side. I'll subtract p from both sides. So I got 3 is equal to 3 is equal to just 1p minus 1. And then I'm going to add 1 to both sides. Add 1 to both sides. So I have p is equal to 4. Now I got to check this out. That's my solution. So let's see. I'm going to take this 4 and I'm going to plug it in right here for this p and right there and see if this turns out to be true. So I have the square root of 4 plus 3. Is that equal to the square root of 2 times 4 minus 1? Well, 4 plus 3 is equal to 7, so this is square root of 7. 2 times 4 is 8 minus 1, so that's equal to 7. Is square root of 7 equals square root of 7? Well, last time I checked. If they're the same thing, they would probably be equal. So our solution is 4. We'll check that one. Okay, so we got that one. Sweet, clear ink on that. Okay. So now we got something that looks like it might give us a quadratic. Remember, the first goal is to get this radical by itself isolated. It is isolated, so what we got to do is square both sides. Okay, this is the mistake that everyone makes right here. When we square this side, this square cancels off that, so we're just left with the 23 minus 7n. But this n minus 5, you have to use that box method to figure out what that is. So let's use that. N minus 5, n minus 5. So we got n squared minus 5n minus 5n plus 25. So this is really n squared. We'll bring these together. Minus 10n plus 25. So that's what the left side turns into. And the right side, this side, since we squared, is just 23 minus 7n. Okay? Now we're going to solve this. Because of this n squared right here, we're going to probably have to get everything to one side and factor it. So let's start by adding 7n to both sides. Add 7n. So I got n squared minus 3n plus 25 is equal to 23. And then I'm going to subtract 23, subtract 23. So I got n squared minus 3n plus 2 is equal to 0. Now at this point, I'm going to do my little x thing. I got my 2 on the bottom, my negative 3 on top. What times what is 2? That has got to be negative 3. Well, that's negative 1 and negative 2. So I got n minus 1 and minus 2 is equal to 0. Okay? So those are my two solutions right there. My one solution is n equals 1 from this one. My other solution is 2 from this one. Now let's see if they both work out. Let's see if they work. Okay, we got to check them. Maybe only one works. Maybe both of them work. Maybe none of them works. So we'll start with our 1. We're going to check this 1. So we have 1 minus 5, because I put the 1 in for this, is equal to the square root of 23 minus 7 times 1, because I put the 1 in for that. Well, 1 minus 5 is negative 4. Let's see if we get the same thing. We got 23 minus 7, the square root of 23 minus 7. That's equal to the square root of 16, which is equal to 4. Does negative 4 equal to 4? No, it does not. No, it doesn't. So we know that 1 is not a solution. Now let's try 2. Let's try the same thing with our 2. Okay. So we're going to put a 2 in for the end here, a 2 in for the end here. So we have 2 minus 5 is equal to the square root of 23 minus 7 times 2. 2 minus 5 is negative 3. Is that equal to square root of 23 minus 14? Well, 23 minus 14 is 9. This is the square root of 9, which is equal to 3. Which means this is also does not equal to that. Okay, so since those are not equal, neither of these are solutions, and that means there is no solution. No solution. Type that in. You could even copy and paste it, and you'd be good to go off of that. Okay, we got one more problem to do. This is a very similar problem. I guess since the last one was no solution, this one probably does have a solution. Still got to check it. Clear ink. Let's do this one a different way. I'll show you the other way to do this. What we're going to do is we're going to take this n minus 3 and put that in Desmos. So y is equal to x minus 3. And then what we're going to do is we're going to take that right side, this square root of 3n minus 1, and we're going to put that in Desmos too. And our goal is to see where these cross. We need to figure out where they cross. So square root of 3x minus 2. I believe that's what it was. 3x minus 11. Okay, so let's clear the ink on this and see what we have. Really, the goal is to find the x values of where they cross. And if I look at this, it crosses at this 4 right there. And it also crosses, so we'll put an x value of 4. That's one solution. And our other solution is 5. So we got two solutions. There's 4 and 5 just from seeing where they cross. So we can just take those solutions and plug them straight in to our answer. We put a 4 comma 5. Check that out. And there you go. So that's how you do the problems. This is some of the ways you can do these problems on this